Hello. Okay, guys, we are live. Right. So, hey everyone, this is me, Harshal Jain, aka Viraj, and today we are going to complete this game. So, in part 1, we built the basic UI and we actually built a simple function which, on changing its value, the rat moves to those coordinates. Okay, but today we are going to complete this game, and now if I just press my arrow keys, you can see that if I press downward arrow, my rat is moving, but if I press my left arrow, I mean the right arrow or left arrow, you can see that it's not moving because there is no space. But if I press my upward arrow, you can see that it's moving. Okay, so yeah, you can see that on downward arrow it's moving, on right arrow now it's moving, on top it's moving. So yeah, I have added the boundaries also. So if suppose in this case, if I want to move upward or downward, it won't move because there is no space. But if I want to move left or right, it will move because we have space. Okay, so I have assigned the upward, downward, left, right arrow keys, and you can assign that. And you can see that if I reach the goal, the alert comes here. So instead of this alert, you can show anything, a pop-up screen which shows a rat eating the food, whatever you want. Okay, but I tried to focus more on the logic rather than this external you won the game type things. Okay, so you can add your accomplishment UI if you want to add anything, but instead of that I have just shown an alert. You can see that if the rat reaches its food, you can see that it's showing you won. Okay, instead of that you can show a page popping up. All right, so that's up to you. So now we are going to finish this one, and all of the levels are working. Suppose I was in level 3 previously. Now if I try to play the same game in level 2. All right. Yeah, you can see that the game is playable, and if I play this on the same level, you can see that now I am able to play this game. All right, so I'll just show you the few things which I wanted to tell you about, and then we can continue. All right, so just a minute. So in the description, you'll find this link. This will take you to this full stack bootcamp course, and this link is actually written after the text project building sessions coming up. Register to our full stack bootcamp course for free. All right, so this is a free course, and just press on the link written given after that text. It will take you to this page. Just start this course and then you'll end up to this page. All right, so in the live section, you'll see that we have upcoming projects on 21st and 22nd January. The project name is Let's Build a Real-Time Weather App using JavaScript and Weather API. So this will be a two-part project, part 1 and part 2, and on 21st and 22nd January 6 p.m. onwards. So the links will be provided here and you can check that out. All right, so I guess on 21st and 22nd they will schedule, GFG will schedule the meeting. It will be a Zoom call, and you'll get the link here. All right, so you can watch this session, and if somehow you aren't able to watch this session, you can definitely check the recordings. That recording will be available here. Okay, and you can check out these text-based theory material, so you can check them out. And now we can continue, and don't forget to enroll for this one. This is a really great course because it's free, and all of the stuff required for a full stack bootcamp, full stack career is available in this full stack bootcamp course. So yeah, you can check this one out. And one more thing, do visit my GitHub repository. So for visiting that, you can simply search my GitHub profile, github.com/virajj014, and this is my profile. And you can see that I have 96 followers, so just follow me here. Let's complete 100. All right, so in the repositories section, we have all of my repositories. And if you want to find this project, that is JS rat in a maze. So somehow if you don't see this one, you can simply search it here, JS underscore rat in a maze, rat in a maze. So you can see that we got rat in a maze, and this is basically part 1, and I'll just shift upload part 2 here. All right, so that will be the project. And if you think that there can be more updates on this project, you can definitely contact me, and also you can share my share your own codes in the comment, or you can contact me on Instagram. All right, if you face any difficulty or you have any confusion, you can contact me here or you can comment below. All right, so now let's continue, and I'll open the code with VS Code. So yeah, this is my JS projects GFG, and in the rat in a maze folder we were actually building this project. So yeah, this is our project, and this was actually our project. You can see that this was completed yesterday, and we need to add a few more changes to this one, then we can actually consider this as completed. Okay, so part 1 was completed, and you'll find that on GFG development channel, a YouTube channel, and just watch that if you haven't, because the part 1 actually built the logic for how to make this maze. Okay, so this maze logic was explained in part 1, and in part 2 we'll actually apply the logic for the movement of the rat to achieve its goal. All right, so I'll just split my screen so that we can view the changes at the same time, and I'll just open it with live server first. So you can see that here's our day 1's project, and right now the rat isn't moving, but the UI part was completed. Okay, all right, so I hope the code is visible, and if it's not visible, you can just message on the live chat. I'll just increase the size, but I guess it will be visible because it works for everyone. And also, if you are watching on a smaller screen, you can increase the quality size, video quality size. All right, so right now I'm just removing this because the logic was explained yesterday, so it's of no use right now. And now I'll complete this game. Okay, right now if I just press on any keys, upward, downward, left or right, the code is the rat isn't moving because I haven't applied the logic. Okay, so to apply the logic we have to check the keys movements. Okay, so for that I wanted to introduce some changes first. All right, so I guess in body everything was okay, in h1 tag everything was okay, in maze container everything was okay, then in row everything was okay, then in a cell just remove this border. Okay, just remove this border for cells, and same for this one. Okay, it's of no use now. Yesterday we had to actually explain you this one, so that's why I gave some borders, but right now it's of no use, and these borders were actually manipulating the actual width and pixels, so that's why I removed the border. Okay, so just comment these borders out, and I guess there was no more. Okay, I guess all of the changes have been covered. And one more thing, like if the rat reaches its goal, it must be above the cheese. So that's why I'll make it as z index 1. Okay, so yeah, these were the changes which I wanted to introduce, and now we can just change the. I'll just copy these stylings. Like I'll just copy these stylings, and also I can cut these stylings. Okay, and I'll just create a new file here, style.css, style.css, and I'll paste them here. Okay, and then you can import the stylings here from the link tag mentioning the path. All right, so the css is imported from this file. All right, so I'll just remove this style tag, it's of no use now. All right, so this was the basic change, these were the basic changes which I wanted, and then we can continue with the JavaScript part. So let's start with the first line of the JavaScript. You can see that I have introduced three levels, okay, which were created yesterday: level 1, level 2, and level 3. They were created yesterday, and I explained how you can build your own level. Okay, this is level 1, level 2 will be something like this, level 3 will be something like this. So you can see that I have increased the complexity to show you that it will work for every case. Alright, so after this I have created a maze array, initializing it with level 1, and on change of this select array, level changes with this. Okay, and once the level changes, you can see that I have assigned that to the maze array. Okay, so level, any level, and in any level, maze array will change. Okay, so yeah, you can see that I have assigned level 1, level 2, and level 3, and this was done in the previous video. And don't forget to reinitialize the inner HTML of maze. Okay, what is maze? Maze is nothing but this container. Okay, maze container, this is our maze. Alright, so you can see that it's initialized with these values, but once you add a level, then the levels maze is added. Okay, so just make sure if you change a level, you have to reinitialize, and then create maze is called, which will create our maze. You can see that black and white, these boxes are created because of this maze function. So this was explained yesterday. Do check out that video. All right, so I hope this much was clear. And after that, we also created these functions which manipulate the value of red. So suppose I uncomment this, and if I just save this, you can see that now the rat's value is updated. If I see this again, and it's not working for all cases, but you can see that it actually manipulated for level 1 at least. So if I just reload, you can see that it manipulates the values of the rat. Alright, so for any level I want the same. So for any level, if I want the same, I'll simply make it 0 0. It actually reinitializes the value, that's why I'm giving it 0 0. Okay, I want to reinitialize the value of rat and fourth position, whatever it was. On change the level, create on changing the level, create maze is called, a new maze will be built, and the rat position, fourth position will be reinitiated. Okay, so these will actually call these functions. And here you can see I have manipulated the style top and style left, style bottom and style right of both of them. Alright, so this much was done in the previous video, and I guess we don't need to add anything right now. Alright, so after this I want to add some logic. So what logic was actually I wanted to initialize the value of rat in the array also. So suppose I am on level 1, this will be my level 1. So if I want to add some add a position of rat, I'll just assign a number to rat. Suppose I'll assign 2. 0 is for what? 0 is for wall. Okay, 1 is for what? 1 is for empty space. So I'm choosing 2 as my rat's position. Okay, that's the logic. So if I just write 2 here, it will work, but it will consume the logic for the empty space. So that's why I'm not writing anything here. Okay, level will be same, but I will actually initialize the value of rat here. So if the value of I is 0 and j is 0, that is the first box. If this is the case, then that's the rat's initial position. That was my point. Okay, so I guess it's of no use right now. If you want to remove this, you can definitely, but let it be. Okay, it will actually change the position of the image of rat. Okay, not the position, not the actual position. Okay, like suppose if previous position of 2 was somewhere in the between of this array, so this function won't change that. This function will only change the position of the picture. That's why I have applied this function. And now here inside this one, you can simply write if I equals 0 and j equals 0. That means we are in the first box. And now if this is the case, then simply I'll just make that as 2. Okay, I'll just make it as 2. So you don't have to change anything. If you want to change, you can definitely change it from here only, but what I did was, for any level, the first position will be marked as 2. Okay, so this will become 2 and so on for level 2 and level 3. Okay, so the first position, 0th row and 0th column will become 2. All right, So that was the logic, simple logic for rat's position. Rat's initial position will be defined in the 0, 0 index, and I have denoted the rat as 2. Alright, so after this, let me just write it here. Okay, 0 is wall, 1 is space, and 2 is rat. Okay, 2 is rat. Alright, that's it. So after this we can do one thing. I have initialized the value of rat as 2, and it will be in 0 and 0 index. Now we can create another function which will give us rat's position. Okay, which will give us rat's position. Why am I taking rat's position? Because suppose rat is in 0 comma 0. If rat's position is 0 comma 0, then he can't move 0 comma 1. He can't move in 0 comma 1 because in 0 comma 1 we have a wall. Okay, that's the reason. So first we have to find the rat's position, then we will check if he can move in any direction or not. Okay, so for that we can create a function, and function name can be this function get rat, position. Okay, so get rat position, and what will it do? It will actually give us the position of rat. So I'm just initializing the position with some value, position equals blank. All right, and what I can do is I can just give it a value of 0 comma 0 initially, or since rat is in 0 comma 0, to make sure our code is working properly, I'll just assign it first as -1 comma 1, just temporary value. Then we'll check the position of 2. Okay, wherever is the position of 2, that will be the position of rat, right? So for that we can simply call this loop again. Okay, I'll just call this loop, and I guess okay, here it was, and inside this I have created this for loop. Okay, so you can just copy this for loop again and you can paste it here. And what's not required is, okay, we haven't copied the whole for loop. Actually I'm lazy enough, that's why I'm copying this, but you can write the for loop again. Okay, so yeah, I'll just paste my for loop here, and then just remove this. Also you can remove this part, and also you can remove this part. Okay, so this was our simple for loop. And what we actually want to find, that suppose I am on 0 comma 0, I want to check that if 0 comma 0 has value 2, then the rat's position is at 0 comma 0. If 0 comma 1 has 2, then rat's position is 0 comma 1, and so on. Okay, so I'll simply say that if the value of 0 comma 0, that is maze array I j equals to, that simply means what? You can see that we while initializing the maze, we can see that we have initialized 0 comma 0 uh, as 2. Okay, so yeah, we are simply saying that for finding the index which contains value 2. Okay, so we can see that initially obviously 0 and 0 will contain 2, so it must return 0 and 0 for the initial value. Okay, so I'll just check position 0 as I and position 1 as j. What is this position? Position 0 is simply this value, and position 1 is simply this value. So it will simply become 0 and 0. Okay, because the value of 2 is 0 and 0 initially. Okay, so for initial case it will become 0 comma 0. And to check, that's why I wanted to check, that's why I've given it as -1 and -1, so that it will convert to 0 and 0 later on. All right, so yeah, this was the initialization, and then we can simply print this console.log position, and we can also return position. All right, so when will we call this function? We'll check this function, and to check this function I'll simply write get rat position, and this function will be called. Okay, so in the console you can see we got an array, and I guess it's not updated. Why it's not updated? Let's check it again. And we got this 3. Why are we getting this? Let me just check what happened here. Okay, let me just do one more thing. Is it working or not? Okay, we can check that again. So in the console, if I just change this, and you can see that we got the initial value. Why? And that's, I guess that's happening because the function is not running properly. So what I can do is I'll just call this function here so that get rat position. Okay, now it's 0 and 0. Actually it didn't initialize, this loop couldn't run properly, and we called that function right away. That's why it happened. So yeah, you can see that rat's position has become 0 and 0. Either you initialize with anything, you can see that I have initialized it with -1 -1, but in this loop you can see that the value which matches with 2 is 0 and 0. Okay, because initialized with 0 and 0. Okay, so that's why it's returning with returning 0 and 0. This function is returning 0 and 0. All right, so we got the rat's position. Okay, we got the rat's position. Now we are about to check that in the 0th row, this is the row and this is the column. In the 0th row, does the 0th the current position must be blank. Okay, that's common sense. The next position, okay, if I press the right button is what? Right button is 0 comma 1. Okay, if I press the bottom, then definitely it will become something else. Okay, so that will be the logic, and for that we'll first target the keys. Okay, what keys are pressed, so we can simply add an event listener. Okay, so right now I guess it's not required here, or you can just add this function if you want. All right, so yeah, you can simply write document dot add event listener. Inside this we are going to add a key down event because that's what we want. So key down, whenever any key is pressed, this function will be called. Okay, so this function is suppose we pass the key as E. Okay, whatever the key will be pressed will be passed as E, and we are actually going to create some variables. The variables are, I'll just reassign this rat as let rat equals document dot get element by id rat. Okay, so this will be our, what happened here is, okay, so the function is now okay. All right, so we have created a rat variable which will target that rat id, and again we are going to target the food, that food, the food id. Again we are going to target the position of rat in left. Okay, rat left equals offset left. Okay, so what is offset? Position of that rat, like distance of rat from the left, that is from the maze. All right, so the left side of maze to the rat. So I'll just explain that later on. You can simply write rat dot offset left, offset left. So what does it simply mean? Offset is a simple property, and you can watch my previous project also. In the Pong game also contains this offset property, and I explained that with a presentation, so you can check that out. Offset simply means if this cheese is here, the distance from cheese to the left side of the box, okay, outer parent, that is the parent, parent right now is the maze for this cheese, so the distance is simply offset left. Okay, same if I want the distance from top to this cheese, this will be what? Cheese dot offset top. Okay, food dot offset top, that will be this distance, 3 boxes. All right, so that's what this offset says. We want to find the distance from the left side. Okay, so for right now the distance is 0 pixel, you can see, but for some distance it will return some value. All right, so we got the left value, and again for the top, again for the left of food, again for the top. Okay, so we got 4 distances from left and top, and we also want the rat's position, so I have just stored the rat's position in this variable rat position. All right, so whatever the value will be returned will be stored in this, and now we can compare this, that whether the rat can move forward, backward, left or right. Okay, so for that first we need to know which key is pressed. Okay, if the right key is pressed, then we have to check if the rat can move right or not. If the key pressed is up, then we can check can the rat move upward or not. So for that, first let's check what key is pressed. So for that we can simply write e dot key, because we have passed e as a parameter for keys. E dot key equals what? So just make sure you write the correct spelling, arrow, capital RIGHT. Okay, let's first check for right, and similarly we have to check for left, and similarly for up, and similarly for down. Okay, so these will be the keys and you can check the names. All right, so after this we have to check that whether first let's make the rat move. Okay, so for making the rat move, what I want is the rat can't go outside this container. The rat can't go outside this container. Acha, if I make the rat go outside this container, what will happen? Suppose if I write, if I increment the rat left by 50, because each box is of 50 pixels. Okay, so if I press this, nothing happens right now because we haven't updated. So for that we can, okay, we have to update that on the rat dot style dot left. So basically it will target this element, okay, this element, rat element from the HTML, and it will increment the old value by this range. All right, so we can simply write rat dot left plus 50 pixel. So for every press, rat will shift 50 pixels. Okay, so if I press on right, you can see that rat is shifting, but it's going out of this box. All right, so for that what we can do? For that what can we do? We can simply apply the logic. Acha, if I try, you can see that for the another box it's happening the same. You can see that it's moving out of this box. So how can we actually make it inside the box? Okay, we can stop it inside the box. We simply want to find the distance. Okay, find this total width, and the rat's distance must not be greater than this width. Okay, let me explain that. For that we are going to apply the simple logic. And here we have how many boxes? Suppose on the case 1, you can see that we have 1 2 3 4. Okay, four boxes. Okay, so 4 boxes, that is length of the maze array will be 4 cross 4, that is 4 in this direction, 4 is in this direction. So for that we need to first mention the condition here. If rat left is less than, and I am going to mention maze array dot length. Okay, length is right now 4, you know the length is 4. Then and we also have to multiply this by 50, because the total distance will be, suppose we have 4 boxes, so the total distance can be what? Total distance can be 15 to 50, I mean 50 plus 50 plus 50 plus 50, that is 200. So that means 50 into 4, 200. But just watch this, we don't need 200, we need 150. Why do we need 150? Because suppose the rat is here, suppose the rat is in last box, so we have 3 box previously. So the value of 3 boxes is what? 3 boxes is definitely maze array length minus 1, that is 3 boxes. Okay, we want actually 1 box less, because 1 box is acquired by the rat only, and we want the remaining boxes, so it will simply give us 150. Okay, so now let's apply the same logic, and if I just do the same for this one, so if I just save this and if I try to move, you can see now the rat is not moving after this. Okay, for any case, if I just go to level 2, it will move till here only, not after this. All right, so this will be the simple logic. And now after that we also need to change the position of 2. Okay, initially the position of 2 was the first, but now the position will be this one, then this one, then this one, then this one, and at the end this one. Okay, so we need to change the position of 2 also. So for that what can we do? We can simply apply this logic, like the rat's previous position will obviously be a blank space, right? Rat's previous position will obviously be a blank position, so we can simply make that as rat position, rat position, and rat position. What will this rat position simply do? You can see that we have called this rat position, it will actually contain 0 comma 0, and its zeroth index, its zero 0th index, and its first index, that's still 0. will now become 1. Okay, I guess I made some mistake. And what's the mistake? Okay, we actually have to pass it as an array. So simply, yeah, what have I done? I've simply called 0 here. I've simply called 0 here, and this also represents 0. So what will actually do? Initially, you can see that the rat position is 0 comma 0. Okay, rat position will return 0 comma 0. So it has taken 0 from rat position 0 index, and again 0 from rat position's first index. All right, and now we'll find that in maze array. In maze array, we'll simply convert that to 1. Okay, before it was 2, now it's converted to 1. Now we have removed the rat from 0 comma 0. Now we are going to increment this. We are going to increment this by how? We'll simply increment this by plus 1. Why plus 1? Because initially it was 0 0 and 0. If the rat moves right, if the rat moves right, the next value is what? The next value is 0 comma 1. Okay, the next value of this is what? 0 comma 2. The next value of this what? 0 comma 3. If the rat moves downward, now what will it become? Since it was 0 comma 3, now it will become 1 comma 3, and that's it. All right, so this logic will be done, and simply you can say that maze array 0th index. Okay, we have targeted the 0th index, and the first column in the in actually the second column, we are actually now targeting the second column. You can see that we have incremented it. Okay, since it was 0 and 0 previously, 0 and 0, we have actually targeted now 0 and 0 plus 1, that is 0 comma 1, and we have assigned that value as 2. So if the rat moves right, the next value will become 2. All right, so now let's check, and if I move right, you can see it's moving right, and we can also call the function here. Okay, so I'll simply call get rat position. All right, so if let me just inspect this, and now let's check if it's working or not. And if I move right, rat position is not defined. Okay, why it's not defined? Line number 181. Okay, what happened here is rat position is not defined. Why it's not defined, brother? Okay, we have called rat position, all right. Then if I simply try to run this, and if I suppose print console.log maze array, okay, so on movement rat position is not defined. Where have I written that? Okay, now let's check what happened. But we have defined rat position, then what's the issue here? All right, so if I just cut it, and suppose if I just simply call get rat position here to check will it work or not. Rat position is not defined. Posing, okay, the spelling was wrong. And now I guess it will work. All right, so if I just simply print rat position, it will return me the same thing, by the way. So let's check the maze array, it will give us a better idea. So now if I move forward, rat position is not defined. Again, have I written any spelling? Rat position, TION. Okay, now I guess it will work. So if I move, you can see that now we have our maze, and the position is 2 here. All right, so if I move again, we will have this, and our position is 2 here. All right, if I move again, we will have this maze array. Now the position is 2 here. So you can see that 2 is updated, 2 is continuously updated, and now it's working fine. And I guess I did a mistake. I could have simply exchanged this 2. I could have simply exchanged this 2 for 0 and 0, but let it be. Okay, I just initialize the value here only. Okay, but you could have initialize the value like this. Also we have changed this value like this. Okay, we have converted 2 to 1 like this. So you could have initialized 2 like this. Okay, 0 and 0 will have 2, but that's okay, that doesn't really matter. Okay, so after this you can see that our maze array is also kept on updating. So this will be really helpful. Why will it be helpful? Now suppose the rat's initial position is this. Now if I want to move right, by the logic right now it's moving right, but you can see that we have a wall next. Okay, so in 0 comma 1 we can see that we have a wall. So if it has a wall, that means the value is 0. Okay, the value is 0 at that matrix point. The value is 0, the rat can't move. Okay, so for that we are going to again apply the same what. I'll just cut this again, and I am going to create another if condition, and we'll merge them later on, but for just explanation I am creating separate if conditions. And now you can see that inside this, what do we want? We can see that if the next box, that is 0 comma 1 for this case, is a wall, that means its value is 0, then we shouldn't move. Okay, or else we can move. So for that, what can we do? We can simply see that if next value is 1, then there is a free space. Okay, so only then this logic will work. So for that we can simply write maze array, and we want rat position, position, 0th index of rat position variable, and okay, I'll just write this, and rat position first index plus 1. So you can see that initially rat position will have what? 0 and 0. So what does this represent? It simply represents maze array 0 comma 1. Okay, we'll find the 0 comma 1 index of maze array. Now what's 0 comma 1 index of maze array? Suppose we are in level 1. So in level 1 you can see in 0 comma 1 we have 0. That means it's a wall. Okay, it's a wall. So we will say that if it's not a wall, then you can move. If it's not a wall, then you can move. So in what case it's not a wall? When the value is 0, when the value is 1. Okay, so for 1 we don't have a wall, for 0 we had a wall. So suppose if its value is 0, that is 0. Okay, you can see that is 0, the rat won't move. Okay, so if I just save this, and if I try to move on right side, you can see that now we can't move. Okay, and let's build the same logic for left, right, left, top and bottom. So right now I'm just merging these if cases, and I'll just make it as and again I'll do the same for this also, and again I'm writing and we need to remove these two brackets. All right, so you can see that now our logic is completed for the right movement, and it will only work when the next box is not a wall. Okay, right now it's a wall, that's why it's not working. If I make it 2, and now if I try to run, you can see that it runs, but again it's a wall, it won't move to the right. Okay, so let's do the same for left and up and down. Okay, so for that we can simply apply the same logic. All right, so first we have checked that whatever key is pressed, if left is pressed, then this logic will work. Again, we can say that the distance we have actually from left, we are actually taking the distance from left. The distance from left must actually be not than greater than 150. Okay, you can say that it must be always smaller than 150. That means this box length is 150. You can say that if the rat won't move outside that box. Okay, this logic was used for that. So similarly, the rat's minimum value must be 0. Okay, must be greater than 0. So for that we can simply write and so in the next line I'll simply write and instead of this I can simply make it rat's position from left, rat's distance from left must be greater than 0. Okay, all right, so this is the simple logic, so rat actually doesn't move outside from left side. Okay, so let me just first update these positions. So now since I want to move left side, so definitely the value will be subtracted. Also, I want to update my style.left again. So now let's check if it's working or not. So right now I'm just removing this and I'll save this, and you can see now it's working. Okay, so since we want the maximum of rat to left is this point, okay, this column. Okay, so for that we can simply say that the distance from left must not be lesser than 0. Right now it's in minus from left side of the box. Okay, right now it's in minus, so we have simply given this. You could have printed this rat left if you want. You can see that its value is negative if the rat goes outside this one from left side, and this value is greater than 150 if the rat goes outside. All right, so now let's save. Now let's save, and you can see the rat won't move outside this box. All right, now again we want to check. We want to check what? We want to check that if the rat can move left or not. Like suppose for any other case, right now I'm just leaving this one. Let's make it for down and upward so that we can add more movements. All right, so just come here and I'll just, for top definitely it will be minus 50, and same can be done for this one. For bottom it will be plus 50. Okay, so this logic will be implemented, and now let's test it first. So suppose if I press bottom and if I press right, okay, you can see now right now it's not moving right, but okay, so for right I am having some issues. Why am I having some issues? Because I am not updating the value of this rat. All right, so for updating this its value, we can simply say that we'll first update it here. All right, so let's first update these values. So we'll apply the same logic. I have updated the rat's position. You can say that I have updated the rat's position. So for left I can do the same, but I want -1. Okay, I want -1 because it's in left, not in right. All right, so I'm doing the same, -1, and again just come here, and again I am going to increment the position, but from what? I'll increment the position from top. So from top I'll simply say -1. Okay, -1, because the row will definitely be subtracted, not incremented. In downwards the row will increment, and upward the row will become lesser. Okay, and I'll just remove this one because column is not required. I'm moving topward, then row is decremented. And again same, I'll just copy this one. And I will increment the row. Okay, why am I incrementing the row? Simple logic. As we move downwards, row increases. All right, so now let's check if it's working or not. You can see now it's working. All right, so let's suppose we are in this case. In this case, if I try to move left, okay, if I try to move right, if I press right button, nothing is happening. Why nothing is happening? The simple reason is we are actually considering this case. This says that if the next 0, 1, initially we are in 0, 0, if 0, 1 has value 0, that means it's a wall, don't move. If the value is not a wall, that means it's 1, then we can move. Okay, since it's a wall, we can't move. Acha, but right now we can move, because suppose now we are in what position? We are in 1, 0. We are in 1, 0. We are checking the same for 1, 1, if I can move right or not. So for right, we are checking that the value 1, 1 is movable or not. You can see that its value is 1. In this level, you can see that we are in this position, and this value is also 1, so we can move. All right, same logic will be applied on these also. So we have only applied the logic for this right one, so we can apply the same logic for this left one also. We can say that the value for left side is 1 or not. If it's 1, then only this logic will work. So suppose if I am here right now, I can move left. Why? Because suppose our coordinates are 0, this is 1, 1, 1, 1, 2, sorry, 1 comma 0, 1 comma 1 and 1 comma 2. Right now we are in 1 comma 2. Right now we are in 1 comma 2. Let's consider this level. Right now we're in what? This position, this one, 1 comma 2. We are about to check that can we move left or not. Yes, we can move left because we have a 1. Okay, so we are about to check for 1 comma 1. We are in 1 comma 2. We are about to check for 1 comma 1 by this. All right, so since 1 comma 1 is 1, so we can move. So that will be the logic. Since 1 comma 1 is equal to 1, then we can move. We can move. You can see that we can move left. All right, suppose we are in this case. Now what's the position? The position is 0 1 2, 2 comma 0, 2 comma 1, 2 comma 2. The rat's position is 2 comma 2. All right, 2 comma 2. Now we need to check, can we move left or not? Can we move left or not? So left is what? 2 comma 1. Left is what? 2 comma 1. So 2 comma 1 is what? 2 comma 1. We can see the left is 0. So we can't move left right now because it's 0, it's not 1. All right, similarly it's for right. Right is also same. You can say the right is this one. So we need to check for 2 comma 3. All right, so 2 comma 3, 2 comma 2, 2 comma 3. So 2 comma 3 is also 0. So we cannot move right. We cannot move right. All right, so we need to apply the same logic for bottom and top also. So just come here and we need to say that, yeah, distance from top must not be lesser than 0. And also one more thing is what? We need to check that the topward index is 1 or not. So suppose I am here, I am in what? I am in what? I am in 1 comma 0. Okay, I am in 1 comma 0. We need to check that is 0 comma 0 equal to 0 equal to 1 or not. So let's check. We can say that, yeah, it's equal to 1. All right, so we can move upwards. Similarly, suppose we are in this case. This is what? This is 0 1 1 comma 0, 1 comma 1, 1 comma 2 and 1 comma 3. So we are in 1 comma 3, that is here. We need to check, can we move upward or not? So to move upward, we need to check this index. We need to check this index. This index is what? 0, so we can't move upward. Okay, so that's what this logic says. That's what this logic says, that check the upward index, check the upward index. If it's equal to 1, then can this logic be applied. All right, same for the bottom one. Same for the bottom one. So we can say that bottom is what? Again, we need to suppose we are in this last box. We are in the last box, and if I move outward, so if I just remove this logic right now, if I remove this logic right now, we can say that maximum I could go is this much. Okay, is this much. So again, if I reload this, maximum I can go is this much. That means 3 boxes, maximum 3 boxes. Okay, that means maze array minus 1, maze array dot length minus 1. So for that we can simply write here maximum can be maze array length minus 1 into 50. That means 150. In this case it's 150. Suppose we have an array of 6 comma 6, then this case will definitely have 5 into 50. That means 250. Okay, 250. 0 1 2 3 4, yeah, 5 boxes, 5 boxes, that means 250. So maximum distance for this one can be 250. Again, for 10 comma 10 we need to check for 9 boxes, so 9 into 5 is 450. So maximum can be 450. That will be the logic. All right, for this case it's only 150. So yeah, we can say that if the distance is lesser than 150, we can move. So now let's test. So yeah, maximum the rat could go is this much, is this much. All right, is this much. All right, so the logic is working pretty fine, and at the end we need to do one more thing. We need to check if the rat could move downward or not. Suppose the rat is here, so rat is in 2 comma 2. We need to check for what? We need to check for 3 comma 2. We need to check for the 3 comma 2. Downward is 3 comma 2. All right, so we are saying that if 3 comma 2 is equal to 1, rat can move. So let's check. So here we can say that 3 comma 2 is, I'm sorry, 3 comma 2 is this one. 3 comma 2 is equal to 0, so the rat can't move. Rat can't move. Rat can't move downward. Okay, if I come here, that means I am in what? 2 comma, sorry, previously we were in 1 comma 1. Suppose the rat is in 1 comma 1. You can say that 0 1, and yeah, the rat is right now in 1 comma 1. That is here. That is here. We need to check the rat can move downward or not. No, it can't move downward, so that means that it is 0, it can't move downward. Suppose the rat is here, this is what, 2 comma 1. All right, sorry, 1 comma 2, this is what, 1 comma 2. All right, so 1 comma 2, 1 comma 2 is this position. We can see that if it can move downward or not. Yes, it can move downward because downward it's 1. Okay, for the same case, 3 comma 2 comma 2. All right, previously it was what, 1 comma 2. Now it's what, 2 comma 2, 2 comma 2. So you can say that it can move downwards. So this logic will be applied for this bottom also. This logic will be applied for this bottom also, and the rat can move downward with all these conditions. All right, so now let's check if it's working or not. Yeah, it's working, and you can see that now it's working. So if I change it for level 2, you can see that now it's working for all the levels. All right, so now you can see that yeah, it's working fine. So what if the rat reaches this final one? What if the rat reaches this final one? Then what will happen? Simply will make it as a win. Okay, that means the rat has reached its goal. So for that we can simply write if rat's left distance is equal to food's left distance. Okay, food's left distance is what, offset left side. All right, so we can simply say if rat left equals food left. Right now I'm just writing this intentionally, so I can simply alert something, alert you win. Okay, so now let's test. If a rat is suppose here, you can say that since the rat reaches here, the distance from left side, that is 3 boxes, okay, is same as these 3 boxes. That's why the rat won. Okay, we also want to check for down top also. All right, so the rat won't win this time, because it has taken the distance from left, it's same as the food but not from the top. So if I now go here, you can see that now the rat has reached its destination and the game has been completed, you won. All right, so this is the logic, and you can see that it's working pretty fine. Where are these variables? These variables are simply assigned here. You can see that I have assigned these variables, so it will work for all cases. All right, so you can say that it will work for all cases. Yeah, it's working pretty fine. All right, so just don't forget these 3 conditions and these updates. Okay, what have I done? I have incremented the value by 50 on every move, and one more thing, I have shifted the value of 2 to the next position of rat. All right, so this is the logic which we have applied, and I hope you understood the logic. If you have any doubts, I can see some people have doubts, so if you have any doubts, you can definitely comment below. And yeah, that's it for the game, and you can apply the more logics on this game, more complexity, more different levels. It will work for each level. All right, so that's why I have taken 3 different levels, so that you get an idea how this game will work for all levels. All right, so that's it for this video, and before ending this video, I wanted to show you something. Just visit the link available in description for the Fullstack Bootcamp course. Okay, so this is basically a Fullstack Bootcamp. You can visit this, enroll for this one, and you can start this one. Here you will get all the material required for a Fullstack Bootcamp, Fullstack career. And in this bootcamp, you can see that we have upcoming live sessions on 21st and 22nd January, so you can check them out. And these are basically on a project that is real-time weather app using JavaScript and weather API. So in this session, I'll actually tell you how you can use the weather API. So just watch these sessions, and the link will be available here. They will be actually Zoom meetings, so the links will be shared here on those days. Okay, so do check them out, and if you aren't able to watch those sessions live, you can check these recordings also. All right, so the recordings will be available here. You can check them out. So I hope you like this video, and if you want the source code, you can definitely go to my GitHub. My GitHub is github.com/viraj014. Okay, this is my GitHub, viraj014, github.com/viraj014, and in the repositories, just find this one, js_rat in a maze, or you can search it here, js_rat in a maze. Okay, so you will find this repository, and here you can use this source code. Okay, so I hope you like today's video, and don't forget to like, share and subscribe. See you in the next one. Till then, bye bye.